Hey guys, welcome to 8.1 video. I'll be going ahead and going over all of our theorems first, so here we go. 8.1 is the Pythagorean theorem. As you can see, we have a squared plus b squared equals c squared, so this might be familiar to you from, say, middle school or something like that. But the most important thing is c is our hypotenuse, so c is what we want to be squared by itself, and then the two legs we're going to square and add them together. Okay, so make sure you write this down. Again, you don't have to use all the words for the theorem. You can just draw a picture and the if-then portion. There's a couple of these, so you can kind of write them a little bit easier. So let's go ahead and take a look. Pythagorean theorem. We also have the converse of the Pythagorean theorem. It basically says if a squared plus b squared equals c squared in a triangle, then we know it's a right triangle. So this is a very quick one. You can just write down as a converse. And then over here we have different ways we can look at a triangle. If the c squared, the largest leg, is bigger than the sum of the two smaller ones squared, then we know it's an obtuse triangle. And then the third and fourth one, actually, the fourth and last one is if the c longest side is squared and it is smaller than the sum, then we know it's an acute triangle. And obviously, if they're equal, it's a right triangle. So let's go ahead and jump into a couple problems. Alright, so here we go. Okay, so here's the first problem. Make sure you write down all the words here and our picture. But what is the length of the hypotenuse of triangle ABC? Do the side lengths of ABC form a Pythagorean triple? So what we have to do is we need to use the formula a squared plus b squared equals c squared. Okay, so c is the hypotenuse, so this right here is going to be c. We always know it's across from the 90 degree, and so we're going to go ahead and do 20 squared plus 21 squared equals c squared. Okay, so you need a calculator because these numbers are really big, so we're going to do 20 squared, and that's 400, plus 21 squared, which is 441, equals c squared. Now we're going to go ahead and add these together, and we're going to get 841 equals c squared, and then we're going to take the square root of it. Okay, so the first thing we want to do is when we take the square root of 841, we want to use our calculator. If it's a perfect square, we're solid. So c equals 29. So it is a perfect square. Okay, that means this is a Pythagorean triple. So do the lengths form a Pythagorean triple. So what is the length? The length is 29. And since we have three whole numbers, they're actual whole numbers, not like decimals or anything like that, then this is a Pythagorean triple. So yes, Pythagorean triple on this guy. All right, let's go ahead and take a look at our next problem. So let's find the length of the hypotenuse. Now we go to find the length of a leg. So let's go ahead and do that. So here again, another picture. Always identify the hypotenuse is across from the 90. That's always the first thing I like to do. A squared plus b squared equals c squared. This time I know c squared is 20. And the legs, it doesn't matter which one's which, so the order won't matter. It's addition, so we're all good. And we're going to go ahead and solve this. We get 8 squared, which is 64. I don't even know why I did that in my calculator. I knew that one off the top of my head. 20 squared we just did, which was 400, plus x squared. And we want to go ahead and subtract 64 from both sides. And x squared is going to equal, just started using my calculator. 336. Take the square root of both sides. And then I'm going to square root both sides. Unfortunately, this doesn't have a perfect square root, so what we're going to want to do is come up with a way to factor this. Okay, so I'm looking at these numbers. Now, if you can, you'd like to pull out a perfect square. So I'm looking at it. I know 2 is going to go in. 2 is not a perfect square. Maybe 4 will go into this. 4 is a perfect square. So I'm going to take 336, divide by 4, and I get 84. So that's convenient. And then let's see. Again, I know 2 will go into it, but if 4 came out of that, that'd be really nice. And it does. and we get 21. Now I know 21 won't break down, but I have 2 4s, so we can get 4 rad 21. Okay, so that is the length of x. So we are going to do a lot of simplifying radicals, and if you have this calculator, you won't be able to use it on the test. Okay, so no simplifying radicals on this guy. We are going to be doing it for real. So if you have this calculator, you can use it during your homework, but you need to use it for that. Okay? So let's continue on. Okay, I just cleared it, so hopefully you got that. Otherwise, pause the video and go back. Let's go on to our next problem. Alright, I think we were doing classifying a triangle, and I think we're done. Woo! Okay, so here we have a triangle with side lengths 6, 11, and 14. We want to figure out, is it acute, obtuse, or a right triangle? So we always want to take the largest one and clarify that is going to be our C, and the other two can just be A and B, doesn't matter. Okay, so let's go ahead and check to see what happens. So 6 squared plus 11 squared, and then we're going to leave this blank. I'm going to put just a box here, 14 squared. Okay, so let's go ahead and see what happens. So I have my calculator out here, and I'm going to get 6 squared. Actually, I know both of these. That's 36, and this is 121, and I believe that's 169, I think, 96, sorry. 13 and 14, they're just reverses of each other. Okay, so we're going to see if they're equal to each other. So 36 plus 121 is going to be 157, I believe, and then 196. Okay, so here's where we can figure out if it's a right triangle or not. If these were congruent, then it would be a right triangle. These two numbers are not congruent, so it's not a right triangle. Okay, one of these is bigger. Notice C right here is larger. Okay, C is larger than this, so C has the greater than sign this way, and because it is larger here, we could go ahead and say that this is obtuse. It's going to be an obtuse triangle. Okay, now let's just really quickly piggyback off of our theorem. So I'm going to jump back. I'm going to leave this here. I don't know if that's weird. I hope not. Let's see here, and let's just cycle back. Okay, so if you see here, if C is bigger, C squared is bigger, then we have obtuse. 196 was bigger, so it's obtuse. Versus if C squared is smaller, then it would be acute. So we are definitely on the right path. This is acute. And I don't think I had to do that. Dang it. So yeah, look, it didn't even move. So yeah, you should get that this is obtuse. And let's just walk you through this real quick. So they go ahead and sort it all out, put the numbers in. Look at, they did the box just like me, and we see that it's greater than, and here it all is right here. Here's our remember portion, and it says if C is less than, it's acute. If it's greater than, it's obtuse. If it's equal, it is a right triangle. All right, guys, that is all for your weekend special today. If you can name the 2 people that were in my video besides me, or if you can name at least one of them, I will give you extra credit. So put their name, write their name, first name only, right next to the top. So 8-1 video, and then in parentheses maybe write their name. Okay? And if you have no idea who they are, then you should just meet people. You need to go out and meet people. And if you don't know their names, I'll give you a secondary option. You can draw a picture of SpongeBob SquarePants. You have to draw him, but I want him to look not like SpongeBob SquarePants, but I want him to look like if you became SpongeBob, what would you look like as SpongeBob? So I think it's a kind of a challenging problem to draw out, but that would be your extra credit bonus. So you can either name one of the 2 girls that were in the video, or you can go ahead and draw a picture of SpongeBob as if you became a SpongeBob SquarePants. So, alright guys, I'm out. We're over. We're done with this place. Chicka chicka woo 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 woo.